In this video, I will explain you about linked list class of Java collection framework. So first of all, I will explain a little bit about linked list. See, this is a structure of doubly linked list. Doubly linked list is a collection of nodes. All these are nodes. And inside a node, this is a data or this is an object. See, in a previous example for an array list, I have taken integer. It can be any type of data, object of any type, right? But all these should be of same type. So this is an object of some type. Here also there is an example of integer. Then this is a pointer to next node and this is the pointer to previous node. So there is no previous node here. Here you can see this is a pointer to a previous node and this is a pointer to a next node. So every node will contain data, pointer to a next node, pointer to a previous node. And this is the pointer to a starting node. So this will be a head pointer or first pointer which will be holding entire linked list. And the last pointer will be null. So this is a linked list structure. This is more flexible for inserting or deleting the element. Suppose you want to insert a new element here at this place. You can create a node. Let us, I want to insert a 10. Then this should point on this one. This should point on this one. And these links will be removed. So 45 will point on this and 3 will point on this one. So now this is how a new node 10 is inserted between 45 and 3. So it's easy to insert without shifting the elements. If it is not a linked list, if it is an array of elements, then inside array of elements, suppose you have same elements 2, 45 and 3, then 1. Then for inserting 10 at this place, we have to shift the elements. This element should be shifted and this should also be shifted. So this should become 1 and this should become 3. Then at this place we can write on 10. So shifting of elements is required inside an array, but in a linked list, shifting of element is not required. In both insert operation as well as a delete operation. So for removing any element also it's easy. You can just modify the links and the element will be gone. Like 45 is again pointing on 3, 3 pointing on 45, 10 will be gone from this linked list. So it's easy to insert and delete without disturbing other elements. So here as an example, we have only 4 elements. Let us assume that there are 4,000 elements. Then if you have 4,000 elements in an array, then shifting them will take a lot of time. So if you are inserting in between the elements, then going for a linked list is better. So this is one reason of taking linked list. Second reason is that this linked list can grow as many nodes as you want. You can go on adding to it. You can go on adding new nodes and you can increase the size easily. But here we cannot increase the size of an array, but we have to create a bigger size array, then transfer all the elements into this one. So then we can provide extra space for new elements. So if you want a size to be more flexible or more variable, then go for linked list rather than array. But the disadvantage of linked list is that apart from the memory for the object, it needs space for the links also. For every node, it needs space for links also. So it will take extra space, but it will provide efficiency in operations like I have explained you. You can decide which data structure you want. So Java provides a linked list class which uses doubly linked list. There is one more linked list called as a singly linked list where there will be a node containing data like 2 and only a single pointer pointing to a next node. Just a single pointer, 45, then next is 3, then next is 1. So this will be a singly linked list, but Java uses doubly linked list. So that's enough. This was the comparison of array as well as linked list. So I have explained you about linked list in comparison with array. Now let us look at the Java documentation where I can show you that whether it is using singly linked list or doubly linked list. Here is a page. I have kept the page open for a linked list. Then here is a description. You can read it that doubly linked list implementation of a list and DQ interface implements all optional list operations and permit all elements, so on and so on. So you can read it out so by yourself. So I have shown you the important point here that this is doubly linked list. Now let us look at the methods of a linked list class by writing some program code. Already in the previous video, I have shown methods upon array list. And almost all the methods are same only, so I will not repeat the methods. So if you have not seen that previous video, please go back and watch that video upon array list. So I will show you few important things that are different in linked list class. So I have the code ready for array list. Same code, I will modify it and show you. I will explain the program again. There is an array list which is of size 20, initial size is 20. Then one more array list which is initialized with list of elements 50, 60, 70, 80, 90. Then in the first linked list, that is array list AL1, I have inserted the element 10, then 5, then I have inserted all the elements of this second list, and then also I have inserted one more time 70, duplicate 70. Then I have set the value, changed the value by giving an index. Then using for each loop, I was showing the elements which are greater than 60. This is where I have stopped previous video. Now see the beauty of Java code. I changed my mind. I don't want array list. I want linked list. I will copy this linked. See this. This is linked list. So this array list, I will change it to linked list. Size, I cannot mention. In a linked list, we cannot mention the fixed size for it or the initial size, because the nodes will be created only when elements are inserted, and they are gone or deleted once the element is removed. This also I will make it as linked list. This is also linked list. That's it. I have changed the objects from array list to linked list. Let the references be same, AL1, AL2, no problem. Whatever the reference name you want, you can take. But you see, all these operations are allowed and they work perfectly. So if you observe here, the underlying data structure was array. Now the data structure is linked list. So comfortably I have switched from one data structure to another data structure, because they are implementing same interface, that is collection. If I run, it will run the program. Yes, it is showing all those elements which are greater than 60. I will go to this show method and remove this condition. Let it print all the elements. So yes, all the elements will be printed now. See 5, 50, 60, 70, all the elements, and the last element is 10. All elements are printed. I will not explain what I am doing here. I told you that if you want, you can go back and watch the previous video. So what all we have learned on array list, all those things you can do on linked list class also. Plus, there are extra things that we can do. Let us check. Before this for each loop, I will say AL1 dot, that is the first linked list. See, the methods are same only. Add with the index, add all. So in array list, there were only 4 methods. Now we have 2 more methods, add first and add last. Yes, these are the extra method because it is implementing DQ interface also. That is the reason. So add first, I want to insert one more element 3 in the beginning, and AL1 add last, I want to insert one element, that is last element 200. So this will be inserted at the last. Let us run and check. Yes, last element is 200 and the first element is 3. So as we have add first and add last, we also have remove first and remove last also. So let us look other methods. AL1, add first, add last, contains, and then this is a descending iterator. You can get the iterator from right to left on a linked list. Then this will give the first element in a linked list. Then get method is there. Get method is same as the method of array list. Actually, this is coming from collection interface. So get and give an index. Okay, you can give an index and get the element at that index. For each, I have explained in previous video how to use this for each. There's a method, but you can give a lambda expression here and you can call different method. Already I am using it here in the program. Then get first, get last is also there. Not just get, we have get first as well as get last also. Index of, last index of, list iterator. Okay, then the peak. Let us look at this peak. It will not remove, just give the first element. Just like we have seen one of the method element, it gives the head element. At peak first element, it will not delete. Peak last, you can know the last element. Poll, so it will remove the first element. It is just like remove first. Okay, remove first and remove last. So actually you have multiple methods for doing the same operation. The reason is whichever comes to your mind, you can use that method. You can call the method. That's the flexibility that you get by multiple methods for same operation. Then remove last. So many methods are there. So you can try out all these methods. So you spend time on this one. This is very important for developing application. Actually, this is nothing but data structures, right? So you should have the sound knowledge of subject data structure. Then you can efficiently utilize them. So the required differences already have explained you when to use array list or when to use linked list. So methods, you try them. So that's all in this video.